Hi everyone, this is Disturbance, Devastation, and Ecological Outcomes in Halifax's beloved Point Pleasant Park by myself, Evelyn Ferguson, Kaylin Collins, and Kaylee Hicks for Dalhousie University. Point Pleasant Park is situated at the southernmost point of Halifax and is the region's most extensive park, spanning around 185 hectares. Its tranquil trails, woodlands, and invigorating sea breezes easily makes it an enjoyable and cherished space to many. It's important to note that the first to enjoy this space were the Mi'kmaq, who hunted, fished, and held various celebrations, as well as traveled far distances to visit Mtukati, which is the Mi'kmaq name for Point Pleasant Park. This translates to spirit or power place. This history is often overlooked and unrightfully outshined by the European history that is seen. In 1749, Edward Cornwallis originally sought out the land as a place for Halifax's settlement, but quickly realized its unsuitable terrain and developed it into a military fortress instead. Remnants of this former European history can still be seen today, but its Mi'kmaq historical significance is unfortunately not as prominent, so it's extra important to acknowledge that here. Hurricane Juan was no friend to the park as it completely devastated the mixed Acadian forest ecosystem on the night of September 28, 2003. Jocham and others conducted a pre-hurricane ecological survey on the urban forest, which predicted it to be especially susceptible to extreme weather events and devastating tree mortality. Since the park's main species were largely coniferous and even-aged, which are factors known to increase tree vulnerability, it was inevitable for Hurricane Juan to leave a lasting impact and wipe out nearly 75% of its trees. Despite the devastation, a silver lining arose when Dalhousie's biology course, the one we're in now, decided to study the disturbances seen at Point Pleasant Park and collect data to better understand ecological succession in urban forests. This presentation will interpret the regression analyses done by former students on total density, average diameter at breast height, species richness, Shannon diversity, Pylos evenness index, and population size for both dominant species red spruce and red maple. We will discuss the forest's observed changes over time and predict the likely outcomes on community metrics and dominant species density as the area continues its hurricane recovery. This slide contains the associated hypotheses for question 1, 2, and 3 that were given to us in this assignment.
Our study was conducted at Point Pleasant Park in Halifax, Nova Scotia, Canada. Measurements were taken annually during the last week of September to the first week of October from 2004 to 2023. Note that 2005, 2007, 2016, and 2020 were excluded due to hurricanes Ophelia, Noel, and Matthew, and COVID-19, which prevented data collection. Data was collected at 6 replicate 20 by 20 meter sites located southeast of the Tower Road entrance to the park. The data collection sites were selected in areas with the highest hurricane disturbance to forest structure. All measurements were taken by Dalhousie University's Biology 2060 students supervised by an instructor. All living trees greater than or equal to 2.5 centimeters in diameter at breast height were considered. Diameter at breast height was measured using a measuring tape to the nearest nanometer at 4.5 feet off the ground in one plane perpendicular to the stem. The species of all living trees within a site was identified, and the number of individuals of each species was recorded. These data were used to calculate total density, species richness, Shannon diversity index, and average tree size. Linear regression analyses were performed for each variable of interest using RStudio to assess whether ecosystem recovery has been linear.
Regression analysis was used to determine the change in total density of Point Pleasant Park since 2003 in Graph 1. There is a strong positive relationship between the years passed since Hurricane Juan in 2003 and the total density of Point Pleasant Park. We can reject the null hypothesis, that being there is no change in total density of Point Pleasant Park since 2003. The data allows us to determine that the total density of Point Pleasant Park has continuously increased over time. Regression analysis was used to determine the change in Shannon diversity value in Graph 2. There's a positive relationship between the years passed since Hurricane Juan in 2003 and the Shannon diversity value of Point Pleasant Park. We can reject the null hypothesis, that being there is no change in the Shannon diversity values since Hurricane Juan in 2003. The data allows us to determine that the Shannon diversity value continuously increases over time. As seen in Graph 1, there's a continuous increase in density since Hurricane Juan in 2003. As seen in Graph 2, representing the Shannon Diversity Index of the park, once again we observe a positive slope from the regression analysis. This allows us to determine that the diversity of Point Pleasant Park continuously increases after 2003. Analyzing the data, we can determine that an increase in both these values are due to the forest recovering after the effects of Hurricane Juan. As supported by the findings in Naley et al. 2004, many tree species had rapid regeneration time. Different tree species regenerating after Hurricane Juan is a finding consistent with the data provided by graphs 1 and 2, as this is an indicator of recovery. When considering what will happen as the community moves towards its climax, we can conclude that the amount of density and diversity of the communities will stabilize. As we get closer to the climax community, the density of Point Pleasant Park will not be climbing at such a high rate. There's only a certain number of species the ecosystem can accommodate with the space and resources available, meaning that the density will stay relatively the same. When it comes to the diversity, once the density reaches a stable point, the diversity will stop increasing at such a high rate as well, because there are not as many new species arising. Point Pleasant Park's diversity index, as well as the total density, will begin to look relatively the same through the years as it reaches its climax community.
To assess how dominant red spruce and red maple species responded to Hurricane Juan in September 2003, two simple linear regression analyses were done to explore the relationship between tree composition and time after the hurricane. Firstly, there was a significant positive relationship between red maple composition and time, which suggests the red maple composition has increased from 2004 to 2023. Secondly, there is a significant positive relationship between red spruce composition and time, which again suggests that the red spruce composition has also increased from 2004 to 2023. Therefore, we can reject the null hypothesis that there is no significant relationship between red maple, red spruce composition, and time. The composition of red maple and red spruce can be equated by the equations given in my script. And it is important to note that although there is a significant positive relationship in both red spruce and red maple composition and time, expressed by the very small p-values, their R-square values are both very low, meaning there's high variability in the data, and it does not fit well to the linear regression model as seen in both of my figures. Therefore, this model may not be a reliable tool to make predictions about ecological succession in Point Pleasant Park. As Point Pleasant Park continues its recovery from Hurricane Juan, there are factors regarding succession that must be considered. As Joachim and others predicted, the forest gradually became dominated by mature, even-aged red spruce leading up to the hurricane, making it especially susceptible to devastation by natural disasters. HRM acknowledges that appropriate regeneration measures must be taken to avoid the recreation of a vulnerable red spruce-dominated ecosystem. A hands-off approach, that is letting natural succession steer Point Pleasant towards a climax community of densely populated dominant species, should be rejected in favor of a more hands-on approach. This would entail the development of a diverse Acadian forest, promoting the planting of native species and encouraging structural heterogeneity to increase the urban forest's ecological integrity. Figure 1 and Figure 2 show a trend of increased red spruce and red maple density since the hurricane. However, we predict these species will reach a steady state as the park attains its climax community. Although these dominant species play an important role in re-establishing a mature tree canopy, it's fair to predict a new and improved climax community will be established due to HRM's efforts in building a more resilient, diverse ecosystem at Point Pleasant Park.
To assess species richness recovery after Hurricane Juan, we performed a simple linear regression analysis. Our study found a significant positive linear relationship between species richness in year with an R-squared value of 0.64. Mean species richness was 4.2 times greater in 2023 than in 2004. We reject the null hypothesis in favor of the alternative hypothesis that there is a significant positive relationship between species richness in year following the hurricane. Increased richness following an ecological disturbance is characteristic of succession theory as described by Moles and Cahill. This is due to an increased availability of resources for the recolonizing community. We found a significant linear increase in species richness over time, which is consistent with succession theory. Secondary succession typically involves an initial rapid increase in richness during the high successional stage, followed by a stage of thinning before establishing stability. The relative abundance of red maple, a shade-intolerant pioneer species found in the park, suggests that the forest is still in the high successional stage. However, our study found a peak in richness during 2018 and a relative evening out in richness since then. Thus, I suggest that the park is currently in an intermediate between the final stage of high succession and beginning to enter the thinning stage. As succession continues, we can expect to see species richness stabilize and begin to decrease as competition increases. In particular, the canopy will likely continue to develop and limit light, thus advancing the ecosystem to the thinning stage of succession and moving the forest towards its climax community.
To conclude, Hurricane Juan has had a large impact on Point Pleasant Park. However, the data collected allows us to determine the park is in recovery based on the continuous increase of total density as well as diversity, and will eventually reach a stable climax community once again. Regarding succession, the forest is undergoing a substantial increase in both red spruce and red maple density. The regeneration measures taken will prevent an overtake of the dominant species red spruce, leaving behind a diverse Acadian forest. In the future, as the forest reaches its climax community, we can predict the red spruce to reach its level of maximum capacity. With respect to the succession theory, the finding of increased richness after Hurricane Juan is consistent with this theory. As the forest reaches its climax community, we will observe the self-thinning process of succession theory, as light becomes limited by the canopy of other species.
So this question touches on resilience in Point Pleasant Park after the hurricane. So despite the hurricane's devastating impacts on Point Pleasant Park, the event really identified the ecosystem's vulnerabilities and demonstrated how species evenness, diversity, and proper management are crucial in urban forests. Research suggested that prior to the hurricane, the park was extremely vulnerable to natural disasters. Ultimately, its lack of resilience resulted in devastating outcomes, but this served as a learning opportunity and got the HRM to intervene and help improve the park's resilience through regeneration processes. Efforts have been made by the HRM to build a more resilient, diverse ecosystem at the park. With a goal of developing a diverse Acadian forest, the HRM encourages a mixed-age forest structure, diverse forest composition, and preference towards tolerant native species. Therefore, we suggest that Hurricane Juan ultimately strengthened Point Pleasant Park's ecosystem, putting it on track to reach a healthier climax community than before the hurricane.
The disturbance of Hurricane Juan in 2004 left Point Pleasant Park with more resources available for the recolonizing community, thus leading to increased species richness as the forest underwent secondary succession. However, in the case of anthropogenic ecological disturbances, such as pollution or land conversion to agriculture, these disturbances are accompanied by a reduction in resource availability. This decrease in resource abundance inhibits the succession of the ecosystem and leads to decreased species richness over time and a stunted ecological recovery.
The ecosystem recovery of Point Pleasant Park is established by the growth of saplings that survived through the hurricane. Due to the diversity of the ecosystem prior to Hurricane Juan, the sapling survival was diverse, causing the regeneration of a diverse Acadian forest. However, had there been little diversity prior to Hurricane Juan, the surviving young trees would have represented that lack of diversity. In Naily et al. 2004, there is discussion of the advanced regeneration of species. They say advanced conifer regeneration was not well established. Early successional tree species are more likely to become established. This is evidence of the previous ecosystem being reflected in the saplings responsible for the recovery of Point Pleasant Park. All this to say, if there was a lack of diversity prior to the hurricane, there would be after Hurricane Juan when Point Pleasant Park recovered as well.